Good morning students. Today I am going to explain the sets. Sets, as we know, this is the basic concept of the mathematics, and most of the concept of the mathematics depends on the theory of the set. And this theory was given by George Cantor in 1874, and this was a research work, rather it was a research paper that was given by George Cantor. So in this video covers the definition of the sets and different forms of the sets and application of the set. So first we will see the definition of the sets. The set is the collection of distinct objects called elements, or we can say this is the set of collection of this is the collection of distinct objects, and these are known as the elements, or more specifically it is the collection of well-defined distinct objects. So here there is a new word. This is well defined. So now we will see the examples. For example, well defined is a very important term. Means those objects that can be well defined, they are the category of the sets, and those which are not well defined, they are not the category of the sets. So we can understand this with the help of some examples like planets of solar system. Planets of the solar system, all vowels, because they are of the same category, they are the well defined. There is no confusion in this. In the same way, planets of the solar system, there is no confusion. And colors of a rainbow. So these are the well defined objects, well defined things. So we can say that these objects, these are the collection of these well defined objects is the set. On the other hand, following are not well defined, as they may vary from person to person. For example, interesting books. Set of interesting books. It cannot be, it is a not well defined object, because the books may differ from person to person. Some person may prefer to read novels, some may read comics, and some may read some different kind of magazines that may be from the health and etc. So this is not the well defined. In the same way, schools in a city. This is also not well defined because schools in a city, this may vary, this may be inter college, this may be degree college, this may be university, this may be for the children, this may be for the different languages. So we can say there is a confusion. Again there is a confusion in this sentence, that's why we can say this is also not well defined. Third example is favorite food of children. This is also not well defined because the favorite food may vary from child to child. That's why in all these sets of objects there are the confusion. That's why we cannot say, we can say that they are the sets. So they are not well defined, and these are the well defined objects. Now we will see some popular sets. Some sets are very much popular, like first is set of all primes. It can be shown by, this is blackboard dark, or this is like this. This is bold typeface. This is bold typeface. This is like 2, 3, 5, 6, and so on. This is a set of all prime numbers. Second is set of natural numbers. Again, we can show it by bold N. This is blackboard bold. This is blackboard bold, and this is bold typeface. Or this is equals to 1, 2, 3, 4, 5, 6, and so on. This is a set of natural number. This is also very popular in set theory. And third one is set of integers. It can be shown by Z. This is bold Z rather, or sometimes it can also be shown by simple Z, that is not bold. This is equals to, this may be like this, -2, -1, 0, +1, +2. This is a set of integers. This is also very popular. Fourth one is set of real numbers. This is for like this, -infinity to +infinity. So this is the fourth set which is very popular in set theory. And fifth one is set of rational numbers. rational numbers, it can be shown by Q, or this is Q like this, or Q, this is equals to A upon B is such that A belongs to A and B belongs to integer. A and B belongs to integer and B should not be equals to 0. So this is a set of real numbers. This is in the form of A upon B, where A and B, this is a part of the Z, and B should not be equals to 0. Another popular set is set of complex numbers. This is C, or C is equals to X plus IY such that X belongs to real number, Y belongs to real number. For example, 5 plus 6 I. So this is the example. This is another popular set. More sets may be, like we can take another example like set of vowels. It can be, let us say this is A and this is A, E, I, O and U. So these are some popular sets. Now we will see the different forms of the sets, means how we can represent it, how we can describe a set. So normally there are 4 forms. Now we will see. First form is description method. Forms of sets. The first is description method or verbal description. This is also known as verbal description. In this form, a set can be described. A set can be described in form of, a set can be described in a sentence or some verbal form. For example, S is, it can be represented as set of natural numbers. So this is the verbal description. This is example 1. Example 2, like A. This is the, let us say, set of integers. So these are the examples, or we can take other examples. This is the first form, and second form is roster form. This is the second form. This is roster form. This is also known as tabular form or listing method, because in this form elements are represented in a list and they are normally separated by comma. So in this method or form, elements are represented by a list separated by commas within braces. In this method, for elements are represented by a list separated by commas. For example, S equals to A, E, I, O, U. A equals to 1, 2, 3, 4, 5, and B equals to, let us say, like 2 upon 5, 3 upon 7, 11 upon 19, etc. So this is the listing method, or we can say this is tabular form, or this is the roster form. Now we will see another form of the sets, that is the set builder form. Set builder form is basically, this is used when the elements are large, in large quantity. It can be used when, it is to be noted here that it is used when the elements are less. Now the third form is set builder form. This is the third form. In this form, a set is described by characterizing the property Gx. The set is described by characterizing the property Gx, or we can say this is a generalization. For example, let us say this x is such that Gx holds, or this is x is such that Gx holds. It can be written like this, or B, x is such that x belongs to natural number and n is less than 10, or x is less than 10. So this is the way, and it is used when elements are in large quantity, then we use this form. And the fourth form is Venn diagram. Fourth form is Venn diagram, or this is visual representation. This is visual representation. In this form, a set. In this form, a set is described by Venn diagram. For example, let A equals to 1, 2, 3. This is any set. This is containing 3 elements, 1, 2 and 3. So it can be represented by like this. This is 1, this is 2, this is 3, and this is equivalent to 1, 2, 3, and this is equals to A. So this is the another form by which we can represent the sets. So these are the 4 popular forms by which we can represent the set. Now we will see some applications of the sets. These sets can be applied in many areas, like it can be used in physics, chemistry, biology, electrical engineering, computer engineering. If we talk about the computer engineering, then we can use in data structures, like first is in data structures. These are the applications. Applications of sets. So first is data structures. Data structure is nothing but this is, if we relate it, data structure with the sets, data structure is the implementation of the sets that can be used for different operations. And second is for formal languages. Like we are familiar with the formal languages, we are familiar with the theory of automata. In theory of automata, we study about the formal languages, and we know that any language, this is the combination of different strings. So that's why we can say, as we know, a language is the set of strings. A language is the set of strings. Here, this is the implementation of sets. This is the implementation of sets. The third one is we can use in DBMS rather in RDBMS. RDBMS. This is Relational Database Management System. This is a kind of database. So here database is used as a relation over sets. So this is another application area of the computer science. So many areas are there. In other fields it can be used, like we can say This is the fundamental concept of mathematics. Means we can provide the symbols for the real time facts, real world things. So this is the best way that we should use. We can use the sets by which we can represent the natural things. Other areas, this is chemistry. And it can also be used in chemistry to understand the different structures of different compounds. Physics, biology, etc. So these are the application areas. So in this video we knew some things about the sets, that what is the set, definition of the sets, what is well-defined set of objects, or we can say what are the well-defined objects and what are not well-defined objects, and what are the different forms of the sets, and at last various applications of the sets. Thank you.